Chapter 28, Dimensioning. Hi, Joe Cerrone. We're going to talk about dimensioning using AutoCAD. When we look at our chapter objectives, we're looking at being able to create a variety of dimensions with the dim command, create linear dimensions, be able to use continuous and baseline dimensioning techniques, angular, diameter, radius, being able to work with leaders and quick dimensions, as well as geometric dimensioning and tolerancing, or GD&T, and then some editing techniques as we work with our dimensions. So AutoCAD dimensioning is one of the things that makes AutoCAD so popular. It allows you to dimension mechanical drawings, architectural drawings, civil drawings, with these different dimension styles. And so the concept is that we create these drawings in full size in model space, which is what we've always been doing. Okay, if something's 4.75 inches, we draw it 4.75 inches in model space. And then the idea is that we're able to apply these dimensioning techniques by just clicking on the line, and if it's properly drawn, then we'll get that dimension for it. And so dimension placing is fairly automatic. You're going to want to use object snaps when you select the location for like endpoints of the line. And so as we work with dimensioning, we'll use the home toolbar or the annotation toolbar, and then you're able to choose these different types of dimensions: linear, aligned, angular, arc length, radius, etc. You can also access the dimensioning menu from the pull down, and as I said, you can see there's a lot of different types of dimensions that we can apply to our drawings. When we work with dimensions, you'll get the dim subcommand on the dimension menu, and it's sort of like dimensioning is a function of CAD that allows you to annotate it and put the dimensions on it, and then you can put in linear, aligned, ordinal, etc. And so as we look at the dimensions for AutoCAD, we could easily just go to grab a dimension, a title block, and take a look at that. And so if we're in the D2L system, and in the D2L system we have these title blocks that you can download. And so if I were to download a mechanical title block and open that, we would then dimension or create the drawing in model space. And what we typically do is we'll go to Tools, Drafting Settings, we'll turn on a snap and a grid, we'll enable polar tracking, and we'll enable O-snap and O-tracking. And we'll say OK, and we'll get our grid on there. And then if we were to draw the object like it's shown right here, then we can go through and just start to put different types of dimensions on it. And so we can draw just a basic shape with lines. And let's make it about the same size. So here we have sort of a widget that's similar to the widget that they have in the textbook here. And then if we wanted to apply dimensions, what you want to do is you want to go to the dimension layer, and in the mechanical it's called DIM, And then you can use linear dimensions. If you use linear dimensions, you can either click on the endpoints and place the dimension like that. If I turn off the grid, we can still use snap. If I turn off snap, we can do that. Or you could put a linear dimension on simply by clicking on the object itself. And it seems to be glitching because it says select the object, but when I'm selecting it, it's going for the endpoint. So I'm just going to go with endpoints and just place that on there. And so as we place the dimensions on there, it's automatically placed. And then things like the dimension style and things like that are associated within the annotation and the dimension styles area. You can place dimensions either on the Home tab in the annotations with these different dimensioning, or you can go to the Annotate tab where they have more dimensioning in multi-liters and things like tables and things like that. So depending on the dimension that you're putting in, if you're putting in a linear dimension, what they're saying is it depends on the order in which you pick the third point for whether the dimension is going to be a vertical or a horizontal. And so when we go in and we dimension something, if we're dimensioning something with a linear dimension, and I pick this point here with an O snap and this point here, then if I go down, it's a horizontal dimension. If I go to the left, it's a vertical. Vertical meaning it measures from the bottom up, and horizontal meaning it goes from side to side. And then you can click on those dimensions and you can move them with what they call grips. And that's what these blue squares are. And it allows you to change them and move them quickly to make the drawing look nice and neat. Things like being able to place an aligned dimension. So if I come back here and I delete that dimension and I say dim aligned, then it will be parallel to that line and give me the true length of that line. So continuing, as we go through and we put in the dimensions, we can create these different dimensions. You can also use diameter dimensions. It'll put this little diameter symbol on it. And so as we look at adding some other components, if I were to add a circle here, and let's just make that 0.25, and then if I wanted to dimension that, and here's a quick way to put it on the right layer. Match properties, I want it on that layer, there we go. And what I can do is I can go to a diameter, and then it will calculate out the diameter of that component. Or if I wanted to put a radius on, let's say I filleted one of these corners with a radius of 0.125. Then when I went to put a dimension on it, there would be a radius dimension, because it's not a circular, full circular feature. It's got a rounded arc, but it doesn't work exactly the same as the diameter menu. And so you can see that it will put in these measurements for you. And then let's say that we wanted this to be 3 decimal places of accuracy. You can click on the dimension, you can right click, and then you can go to precision and you can dial it up. It's really nice and quick ability to have the dimensional tolerances more accurate. So as we go and we work with these different dimensions, you can put the dimensions in. The easiest way to add text to it, like 2 times, is just to put the text in and then double click on it. And so if I were to double click on this dimension right here, and then it turns blue, and I can move the arrow to the left and I can say 2 times and then green check mark it. And the idea is that you can add text to it, but you don't want to go and say 2 point something here, you know, and I'm just going to go and change it 2.87. Okay, by doing that, you've created an inaccurate dimension. So you can't override the text dimension with whatever number you want just by double clicking on it. but then it's kind of a no-no. It's sort of an inaccurate dimension that we want to try to avoid that. But you can double click on the dimensions, go to the end of the text there, type in TYP for like typical, green check mark, and then if you wanted to move that text, you could do that. Continuing. So dim aligned, same as dim parallel, you get the true length of that inclined line. And then when we look at some of the techniques, what they have is they've got like these quick dimensioning techniques to put dimensions on from a baseline. So this would be the baseline, and then this is the first dimension. The second dimension from the baseline would be 4, the third would be 8. And it's just a really quick way to have dimensions that are nice and neat. And so if we have a dimension if we have something that looks like that part, and use snap when you draw things, they will be more accurate. And so when I go through and I just create stuff, I'll use the snap on it. All right, and let's put this on the object line layer. And then when we dimension this, we can dimension it with what they call a baseline. And so you put a linear dimension on first, and then you choose baseline, and then it will build out a nice baseline dimension. So you say linear, you give it the first dimension. Sometimes you have to move it, hit escape, and then you say baseline. And then you can just tag the other elements, and it will quickly create nice accurate dimensions. And so things like baseline dimensioning, dimension continuous or dim continue, same thing. You just put a dimension in, and then it just keeps them lined up horizontally, and so they're at the same height, and it'll put in the dimension. Just another way to keep your dimensions neat on the drawings. And so again, here's a baseline, and it'll automatically space them for you. Angles can be dimensioned with the angular command. And so what you can do is you just tag the lines, and it notices that they're at an angle, and so what it will do is it will prompt you to put in an angle. And so if I wanted to put in an angular dimension here, I can go to my angular dimensions. I can tag these two lines. Now if you can't tag a line like I'm trying to do, turn off your snap, and then the cursor will respond much better. And so I can put that dimension on, I can move it. If the dimension is too big, like this one is, you can scale it down with what they call dim scale. And typically what I'll do is I'll just go to properties, and then I'll just manually adjust the dim scale for that. And you can adjust everything that's in there, but somewhere in here is a dim scale factor that will allow me to change the height of the text or the size of the text. You can go through and change the manually right here, but the proper way is to use what's called dim scale. And let me locate that. So on the fit tab is where the dim scale is. And so if I have it highlighted and I want it to be smaller, you can go to the dim scale and you can change it. And so if I say 0.5, now you can see it's a little smaller, kind of overrode it, just so that I can keep the drawing nice and neat and accurate. So we can put in angular dimensions. You can dimension circular shapes. Again, you need, that's an angular measurement, so you'd use the angular measurement. You can add radiuses. Automatic dimensioning, this is like a multi-use tool that'll kind of automatically, whatever you tag will be dimensioned, and it allows you to quickly go through and put in what they call quick dimensions. I prefer to show people the manual way of doing it the first time with linear, vertical, and angular rather than going into the quick dimensions as we take a look at some of the objects here. If you're using the automatic dimensioning technique, you can go through and you can highlight what you want to dimension. Excuse me. You just tag it and place it there. Quick dimension. It's not my strong suit, but it does the same thing essentially. And so you have the ability to apply these different dimensions. What's important is that the part is accurate and properly dimensioned for manufacture. So there's a lot of different ways to make the dimensions look neat and organized. That's sort of what we're going for when we dimension parts. You can use some of these advanced techniques. I typically save this for the intermediate course, being able to dimension sort of a section view, or broken out section is what they would call it. There are more advanced techniques. You can jog the dimension. You can dimension arcs. Center marks are created with the dim-sen, and I'll mark up prints because when it automatically puts in the center mark, what I'll tell people is to turn off the center marks and put it onto a different layer. And so typically what I'll do, like for these dimensions here, which have these two center marks, is I'll click on them and I'll go to properties, and then I'll disable the center mark. And then what I'll do is I'll put the dimension in again, since it's gone, on the centerline layer, which is really where they should be. As a person who used to teach drafting, I try to get those to that point. And so I'll teach technique, center marks on the centerline layer, and then you can adjust these center marks with grips. If they're kind of big, you can pull them in. As you see fit for annotation of drawings and dimensions. Same thing with this. If I click on this and then I say, get rid of the center mark, say none, I can then go back and put it in with the center mark tool. And it looks better. You can right away see that it's target the center of that hole. And so that's what we want. We want drawings that are easy to read and to interpret. All right, continuing. And so you can add some of these other techniques like dim break. You're supposed to avoid crossing over dimension lines, and so what they do is they use the dim break to break out the dimension so that it doesn't have the line over the line. Leaders and multi-leaders are used to put notes on and to point to things. And so when we work with leaders and multi-leaders, we have what they call quick leaders, and they go through quite a bit of information on it, but they're really pretty straightforward. If I have a drawing like this and I want to put a multi-leader on it, I can click multi-leader, and then I can choose where I want that leader to be, and then I can place it on and I can call it a leader. And then if I need to move this a little bit, I can go ahead and adjust it so that the arrowheads are properly annotated. And so the idea is to make, again, a neat drawing which indicates some of the things that are on there. It does have a leader style, and so when we look at the multi-leader and the style, you can see when you go left it's above versus when you go right. And so in the multi-leader style, what I typically do is to modify it and so that the landing is the same, middle top of line and middle top of line, whether I go right or left. And then I can apply that. And so that's what's customizable about our dimensions. And then as we continue, it goes through all the different ways that we can go ahead and add these multi-leaders. And we go through this in 117 where we'll add balloons and bubbles, you know, so that we can have assembly drawings which call out the part. And so they would look up, oh, part number 3 is a bolt, and the bolt is this size. Typically how we would annotate or dimension a drawing for blueprint reading. And then the structures of the tabs, like we were alluding to, you can have these dimension styles for your multi-leader, which will allow them to have more than one bubble on it, be able to have a spline or a zigzag, just to make the drawings look neat. But again, these are more advanced concepts. We just kind of want to know about them. I like dim ordinate a lot. I'll use this for CNC programming, and so we'll use ordinal dimensions to dimension some of the parts because it gives us absolute locations. And robotics and CNC machines like to use absolute locations for the parts that they manufacture. So if I was to work on a part that was going to be ordinally dimensioned, what I would do is I would, and we can just take this one that's already here and we can just delete some of the dimensions on it. And so let's just take this one. And so with ordinal dimensions, what's important is the user coordinate system, or this system here, where 0 is located. So I'll say UCS, and then I'll say O for origin, and then I'll put the origin on the corner of the part wherever the 0 location is going to be. And so on this part, I think what I'm going to do is I'm going to rotate it, and I'm going to just rotate it 180 degrees like that. And notice when polar is on, you get those tracking and it's easier. And then if I go UCS and I say O for origin, and I put the origin right here, that's where 0 is on the part now. X and Y meet. And then if you use an ordinal dimension, the idea is that you will tag these lines, and then the first dimension will be 0, and then if I repeat the ordinal, I'll get the next one. And so we can get all the horizontal dimensions from a 0 location. And the same with the vertical. And so we'll say 0 because our X and Y meet there. And there are automated ways that we can put these dimensions on. But the idea is that we have neat dimensions that are easily readable. And so this is 1 inch from the 0 line here. That's ordinal dimensioning. And it's very good for manufacturing. All right, and so here's some more examples of how they ordinally dimension. You can see they're by the user coordinate system. They've zeroed out where program 0 is going to be, or part 0, so that dimensions are going to then be relative to that point. All right. And then, you know, quick dimensions, again, quick techniques that will automatically put dimensions on there rapidly for you. We're going to stay with just the linear, horizontal, vertical. Tolerances, as you get farther into your career with design and drafting, you can put GD and T symbols on drawings. There's a tolerance mark, and then you can input these different geometric dimension symbols like flatness and parallelness and perpendicularity, because as you manufacture things, certain manufactured conditions are more important, and that's a way of communicating on a blueprint things like a surface finish, or that it's got to be concentric or parallel within a certain tolerance, meaning a measurement of how parallel these are. It can be parallel to within 0.003. If it's 0.005, it's going to be a rejected part because it's not within tolerance. And so GD and T symbols, we have some courses in manufacturing, and we do some in our intermediate course, and it's a way of being able to add more information to your drawings. Alrighty. And so they just talk a little bit more about some basic dimensioning techniques, more about GD and T, and making a nice mechanical drawing. They do have some inspection routines that you can run for what they call a basic dimension, which will allow you to have a dimension like an inspection dimension that someone would check, and then it tells them information for tolerance for an acceptable part. And so AutoCAD does everything with dimensioning. You can edit the dimensions. If you double click on them, you can use the grips to move them around. If you explode a dimension, it's no longer what they call associative. And so with dimensions, the way that it works is if I update this drawing by stretching it, and so let's say I stretch this part here from here out this way, notice how the dimensions are increasing because it automatically measures everything. And this is why people use CAD. And so if we were to stretch it in a vertical dimension, you'll notice that those values increase as well. That's because the dimensions are associative. Now if I explode it, so let's say I exploded this, and now when I stretch it, it no longer will update. And so that 196 doesn't change, but the other numbers do because they're still associative, meaning they're automatic. And that's what you want. You don't want to explode dimensions. People will do it because sometimes the dimension's a little bit off and they just want to get the number right on the paper, but it's frowned upon. All right, and so, just more information about editing dimensions, moving them. Grips are the easiest way to move them. And so as you work with your dimensions, you can move them around. You can pull up the properties menu like I did on the center mark and make adjustments, like turning off the center mark or changing the dimensional precision. Here's what we talk about with associative dimensions and non-associative. When we explode them, they become non-associative. They just keep the same number. And so when you change the size of it, associated dimensions will update. And they talk about how to turn off the associativity by right-clicking and going to the system options on the unit user preferences. You can turn that off. Dim reassociate isn't really a commonly used command. You can look into that into the intermediate course if you decide to continue, but it allows you to reassociate or put them back onto a part, and it'll then put them on the right number. It's kind of an odd technique. But as you go through, variables for dimensioning and things like that, here's our associativity. And then they talk a little bit about dim scale. And dim scale is where people in architecture will get a little goofed up because everything is scaled in the drawing so that the text heights are the right size. And so when we create architectural drawings, the scale is bigger because the drawings are bigger. And so we scale or we have a dim scale factor that's within the title block in the dimension style that will automatically keep the proper dim scale, meaning the size of the text. Alrighty. And so that gets us to the end of the chapter, and then here's some of the exercises if you'd like to do bonus work. Alright, that completes our lecture on dimensioning, chapter 28.